This is a standard undivided block of 256 IP addresses, what network engineers refer to as a /24 network. When your HR department moves into the building, they require 30 IP addresses to connect their workstations and servers. At the same time, the sales department needs 60 addresses for their own staff on the different floor. In a flat network, assigning both departments to a single block creates security and management conflicts. Because the network hasn't been divided, the protocol treats the entire block as one single neighborhood, making it completely impossible to isolate the two groups' traffic. This diagram shows the resulting inefficiency. Because you've designated the entire block for these two groups, the remaining 166 addresses are effectively stranded. You cannot assign them elsewhere because the router sees the whole 256-lot grid as one occupied piece of land. This lack of a partitioning strategy leads to massive resource waste. To build efficient networks, you have to treat these addresses as finite digital real estate. The Subnet Mask acts as a precision cutting tool. It allows you to slice large networks into isolated, fenced-off segments, providing a level of control that raw IP addresses lack. A /25 mask makes a single binary slice, dividing the 256 block into two distinct 128 neighborhoods. For sales, a /26 mask slices a 128 block in half, creating a 64 block. Finally, a /27 mask halves the remaining block into 32, the exact fit for HR. This repeating pattern of binary division allows you to custom-size network segments. You can scale the architecture to fit the department, rather than wasting an entire grid on a small team. If we look closely at this 32-address HR block, we can see the specific architectural boundaries that govern every freshly cut subnet. The -2 rule is a fixed requirement of the protocol. Every time you slice a subnet, you sacrifice two IPs. The first lost address is the network ID, the unassignable street sign. The second is the broadcast ID, the megaphone to speak to every device simultaneously. Subtracting these two IDs gives us the final count. A block of 32 total addresses yields exactly 30 usable IPs. This results in a perfect fit for the 30-person HR department, filling every usable address with zero waste. This mandatory 2-address tax dictates exactly how small you can slice a network. If you cut the grid too small, these fixed penalties will eventually consume the entire usable space. This organized map is the final result of the cutting process. It stands in contrast to the chaotic, wasteful state we saw at the start. By partitioning the grid, the addresses that would have been stranded are now preserved and available for future expansion. The Subnet Mask achieves this through the power of binary halves, turning a single monolith into precision segments. You simply have to balance that power of division against the mandatory tax of the network and broadcast IDs. Subnetting provides a system of resource management that grants you complete, optimized mastery over your digital architecture.